OLED subscribers, take a look at that. In this video, I'll show you how to animate like a bit in Android. So going to our recycler view, even that looks something like this. It has this jelly ribbon effect which I kind of achieve with the object animator, and I'll show you how to do this in this video. Now if you remember from our slidenerd channel, if you go to playlist in the last video, I was under material design series where I was at video number 48 talking about RecylcerView animations, and that was the first type of animation with the help of animators that come into the picture or the user sees them when he or she is adding, removing, moving, dragging items inside the recycler view. This animation, which I'm going to show you right now, is the second type of animation which you will witness when the user loads the recycler view on the screen inside a fragment or an activity the way you saw right now. So let's take a look at how we can achieve this both without a library and with a library in this video. Animation is a huge topic in Android and includes a lot of things like how to animate views, how to animate layouts, how to animate with the pre-honeycomb way of doing things, the honeycomb way of doing things, how to define them in XML, how to run them in Java, how to receive updates from an animation, how to ensure that you combine multiple animations together and they work with different order between them, how to evaluate custom types for animation, how to make your own interpolators. And like I said, that's a huge topic and I'll be sparing that for a separate series on slidenerd. But at the time of making this video, I'll be talking about how we can use the ObjectAnimator in Java for achieving our recycler view animation. Take a simple example. Here, you want to set the duration as 40 milliseconds and you want to say that translate my view by 40 units on the x-axis as the duration proceeds to 40. There is a special value called the animated fraction. It goes from 0.0 to 1.0 always. When it is at 0.0, it simply means that your animation has started. When it is at 1.0, you're towards the end of your animation. And it goes to intermediate values like 0.01, 0.02, 0.03, and at each value, you can customize what you want to do with the animation. So here, in this case, at time equals to 10 milliseconds, which is 1/4 the duration, the view has been translated by 25%, then it goes to 50, then 75%, and finally it reaches 100%. Now this is what you call a linear animation. In other words, the rate of change or the rate of change in translation of the view is constant. Let's take a look at a non-linear one again with a simple image that is given right here on Google's website. Now if you take a look at this animation image here, everything is pretty much the same. You go from 0, you go to 40. The duration is 40 milliseconds as well, but what changes is the rate at how you animate or move things in the beginning towards the end. For example, you move to 10 pretty quickly, but you move to 20 a bit slowly. Then you go to 34 a bit more slowly, but you go to 40 pretty quickly. So that is a non-linear animation. And this can be achieved with the help of something called interpolators in Android. So let me show you what kind of interpolators exist out there. If you go to Google and if you simply type Android interpolators, you will notice that there's a nice video here on YouTube that shows you the different types of interpolators. Let me play that as well. So there's the accelerate decelerate interpolator. As you notice, it accelerates. This one keeps accelerating, that's an accelerate. Anticipate will wait a bit and then go towards the final part. There's anticipate overshoot, which goes beyond the target and comes back. There is bounce, as you see that bounces out there. There's a cycle animator that keeps cycling, and then there's a decelerate that will go slow towards the end, fast at the beginning. The linear, which is the constant rate of traveling, and then there's the overshoot, which will bounce beyond the target and come back to its place. So these are the different types of interpolators, and they simply control how the animation moves, whether it moves at the same rate or does it go a bit faster and slower somewhere in between. Start the app, go to the second tab, box office. We have our plain dumb recycler view that does not animate. But one thing is obvious, isn't it? All the data is put into this recycler view in the adapter box office method, especially in the onBind view holder method. And this is where the user first sees the data, and that's where we need to animate. Now the view that we want to animate is the custom layout that each item is made of. For example, it would be the layout for this entire row inside our recycler view, and that can be accessed with the help of our view folder object. So I have a class called animation utils, and it has a method called animate where I give the view folder object. Now inside this animation utils method, I've written nothing here which I'll be showing you how to do. We use the class called ObjectAnimator, and it has the setters and getters that you need, as they mentioned here, to do whatever you want to do with a view. The method that we are going to use is called ofFloat. If you take a look at this method, it takes a variable number of things because the third parameter is a where args from Java. The first parameter specifies the view that you want to animate to. The second parameter is the property name. It can be like translateX, translateY, scaleX, scaleY, rotateX, rotateY, alpha, and so there are some other properties as well. And you can animate your own properties inside your custom view if you have a setter and getter method for that property. The third parameter is obviously the list of values. If there's a single value, it says that is the value is the one being animated to. Two values imply the starting and ending values. More than two imply a starting values to animate along the way and an ending value. Alright, that sounds confusing. So let's take a look at how we can use this with the help of an example. So going back to our code here, in the animate method, I'll simply say ObjectAnimator.offloat. I need to specify the target. In our case, that's going to be the item view, that is holder.itemView. Now notice that I have not made this public inside my adapter in the view holder class. If you go here at the bottom, that item view property is simply accessible from the holder itself. The second thing that we want to specify is the property. Specify that you want to translate in the vertical direction with the help of the translationY property, start at 0 and translate by 100 pixels vertically. So going down, the next thing you would like to specify is the duration. Animation translationY dot set duration, and I'm going to say 1000 milliseconds. Durations are purely experimental. You have to see how it looks when it goes at 200 milliseconds, and you have to see how it looks when it goes at 2000, and then decide which value you think would look the best. So going down, you say animator translate y dot start. So at this point, we should be able to see our animation if we run this. Go down, you run the app. So first, when you go to the second tab, you notice that the first element looks a bit off from the top of the screen, and that's because we have translated everything by 100 pixels downwards from their original position, and that's not really a great thing to do because you're moving objects away from their original position. If you go to the bottom, the animation will work, no doubts about it. If you go down all the way at the bottom, you will notice that the last item is pushed by 100 pixels out of the screen, which probably happened right in front of you. Now this is also the reason why most people, when they animate, they start at a position which is not the original position, and they end at the original or default place of that object. And you can easily do that in this case as well by starting at say -100 and then going to 0. This would simply mean that initially you're at -100 and then you're coming to its original position. So let's run this and find out how this looks. Now when you go to the second tab, everything looks at its place. As you start scrolling down, you notice that the -100 to 0 animation has started taking effect, but it doesn't look that good, does it? Because the items are basically popping from the one above. But when you start scrolling up, you notice that they look pretty good because the items are coming into the scene from -100 to 0. So while going up, the animation looks good, but while going down, it looks stupid or retarded because -100 in this case would begin at the child above it, and then coming to 0 would mean that you would see the animation just the way you're seeing right now on the screen. However, there's a fix for this, and the fix would be to make the animation dual nature. In other words, while going up, since the animation looks good, we can come from -100 to 0, but while going down, we can come from 100 positive to 0. So we can detect whether the user is going up or going down with the help of some if-else conditions, or of course you can use a scroll listener for that. But like I said, I believe in doing things the simple way. So let me show you how we can make this animation better and dual natured. So let's go back to the adapter box office and make a variable here called previous position. Now this will contain in 0 initially. We'll simply go and assign 0 to it, and we'll go down inside the onBindView holder method. Before we animate things, we are going to have an if-else condition. We're going to say if the current position is greater than the previous position, that means that we are scrolling down. Otherwise, we are scrolling up. So we are going to have an else clause here, and below this, we are going to assign the previous position as the current position. So when we are going down, which would be the first case, we don't want the animation that we currently are showing. We'll have this in both the places. What I'm going to do is add a boolean saying going down. So here I'll simply say true, and here I'll simply say false. Going back to the animation utils class, I will add another parameter here as boolean, and I'll say goes down. So if goes down is true, we want to animate from 100 to 0. Otherwise, we want to animate from minus 100 to 0. And we can do that very simply. We can go here and have a ternary operator at this point where we can say goes down equals true, then animate the value as 100. Otherwise, animate the value as minus 100 to 0. Take a look at that. Now when you run the app, you should be able to see a nice animation that goes dual in both directions. Let's take a look at that. So there's my adapter at this point. As I start going down, take a look at that effect. Things come from 100 to 0. And as I start going up, things come from minus 100 to 0. And that is how you animate a recycler view in Android. Now you can specify a bigger value and that would make the animation a bit longer. Let's say 300 minus 300. Now remember, all these things work in pixels. If you want dps over here, then you will have to write your own converter from pixels to dps and then do it in your animator recycler view. Now when you go, you take a look at that translation. It's bigger now since we are saying 300 to 0. As we start scrolling up, it's minus 300 to 0, which again looks pretty good. So now let me show you how we can do a more complex animation like a vibration animation. So going here back to our animate method, I'm going to have one more animator defined as ObjectAnimator, and this time I'm going to translate it along the X, but I'll do it several times. I'm going to say offFloat. The target should be holder, item view. The translation that we want to perform this time would be translationX, and here I'm going to have some custom logic. Remember, we have a float values parameter. Now this simply means that we can have several values and the animation will go through all those values before coming to our original value. For example, we can say initially the translation should be minus 25, then it should be 25, then it should go to minus 20, then it should go to 20, then it goes to minus 15, 15, minus 10, 10, minus 5, 5, finally it comes to 0. So this would be our shake animation. Now we want to combine these two animations together. First of all, we need to store this inside a variable. We can say animator translateX, and we are going to make an AnimatorSet, which is a special type of object that lets you group animations together. Here I'm going to simply say AnimatorSet at the top and make an object of that by saying AnimatorSet equals to new AnimatorSet. Now I don't have to specify start for any of the animators that I have made. I'll set a duration here for the animator translateX by saying set duration 1000 again. This time what I'll do is go to AnimatorSet and say play together, and I will pass both animations here. So I'll say animator translateX and animator translateY. Play both of these animations together, and then I'll say AnimatorSet dot start. So now when you run the app, we should be able to see the translate happen in the Y, and at the same time the kind of vibration happen in the X. So let's take a look at this in action as well. And like I said, these values are going to be iterated till it finally comes to rest at 0. So now when you go here, you notice as you start going down, take a look at how they come inside the sea. They're all shaking up and coming inside the view. Initially they go to minus 25, then they translate to 25, then they go to minus 20, 20, minus 15, 15, ultimately they come to 0, which is what you see here. And as you start going up, you notice that things are again shaking up pretty violently and coming into the picture. And you can increase the value of say minus 25, you can make this minus 50, go to 50, and you can say minus 30 here. 30 is all about experimenting the values. Like I said, you go to minus 20 and you go to 20, and you don't even have 10 anymore. You simply go to minus 5, 5 and 0. Now this would give the animation a slightly different effect when we run the app over here. So go down here. Now if you take a look at scrolling down, you take a look that the animation becomes a bit more wild in our case. Wow, that looks pretty good, doesn't it? So if you go up top, the animation is going to repeat, and look at the way it comes into the picture. So you can do anything with this. Think about it. You can scale, you can rotate, you can do whatever you want, and that would be the best part about it. The AnimatorSet can combine everything together. You don't have to set the duration on each of these animations. You can set the combined duration on the AnimatorSet. You can also set an interpolator like the anticipate interpolator on the AnimatorSet. I have used the scaleX and scaleY animation as well. Combined together, that's 4 animations playing together in my case. Now when you see, you go back, you see this is my app, this is how my app starts coming in. There's an anticipate interpolator and other things are coming into the picture as things start over here. You go up, the animation reverses exactly in the nice manner, making things pop up in a weird way inside my app. So enough with this. Let's go and take a look at the Android animations library available to us for doing all this. You can see Android animations library, and there is your one Damagia or Damagia, sorry, I can't pronounce that. So going to an Android View Animations library here, there's a Gradle dependency. We can simply add it and get our stuff done. There are three of them. Just take them, copy them, go to your app, that is build.gradle file, simply paste them over here. And once you do that, make sure that you sync your project with the Gradle files by saying sync now, at which point it's going to start downloading those library files. So if you see his library, there's a huge list of animations he has. There's attention, special, bounce, fade, flip, rotate, slide, zoom, and there's a whole lot of types about it. And feel free to use them on any of your views. It doesn't have to be a recycler view. You go to the top. These are the three lines that you need to write. First is the technique, then duration, then which view you want to play it on. So let's go back to code. I've commented everything out, which you can find in the GitHub library, github/slidenerd. So going back to yo-yo here, I'll say yo-yo.width. I'll specify which technique. That's going to be wobble. In my case, that's going to be techniques.wobble. The duration that I want to play that for is 1000 milliseconds. Again, experiment with it. Play on holder.item view. So at this point, let's take a look at how this animation looks. So there's going back to our recycler view, and this is what the wobble animation basically looks like. Okay, it's pretty close to what I just made here. Go to the top. There's a nice effect that you got there, but it's not very subtle. Recycler view animations are expected to be subtle as per material design. So now I went back and changed the technique to a rubber band, and if you take a look at how that looks, this is what the rubber band basically does. It scales along the X, I believe, and then it comes back and compresses itself a bit to give you a rubber band effect. So you're welcome to experiment with all these libraries. By the way, at the start of this video, I showed you an animation. It's here right in the comments. For both the toolbar, that part, and for the recycler view, that part, both the animations are over here. Code for everything is available on GitHub/slidenerd. Go to repositories and take a look at the material design test app. Before I conclude, there was a bug in video number 47, which only one person has managed to bring to my attention. Nikita Axionov, thanks for that. Hope I pronounced your name correctly. The bug is about some parse level value. You can read this by coming to the comments here, but if you go to my studio in the movie class, I have fixed that bug and I'll be uploading the fix today. So if you like what you saw, let me know in the comments which animator you think is the best. If you have made your own animations, be sure to share that code right in the comments and let other people know what they do as well. I'll catch you guys in the next video. I'm not sure what that is gonna be about, but if you like what you saw, please like this video, share this video, subscribe to Slide Nerd, and let us know your thoughts in the comment boxes below. Thanks for watching. I'll catch you guys in the next video. Have a nice day.